Welcome to the Frida Learning Series, brought to you by NowSecure. This is Module 2, Frida's Internal Tools. In this module, you'll gain some important insight into the tools Frida comes packaged with and how to use them. Pay attention though, these tools will be an integral part of everything you do with Frida from here on out. Ready to get started? Me too. Let's review what Frida tools are before we dig into each one. Frida provides a set of tools that can be used to hook into running applications to inspect and modify their behavior in real time. These are a set of command line tools that provide a higher level interface for common tasks, such as listing running processes, attaching to processes, and loading scripts. They also provide a command line interface, or CLI, that allows users to manage and start instrumented processes, load scripts, and interact with the Frida server running on your phone. Let's start with the Frida CLI. The CLI is what's known as a REPL, or a JavaScript read, execute, print, loop interface. Simply put, that means it takes single user inputs, runs them, and returns the results to you, the user. The CLI allows us to run a variety of JavaScript commands, interact with the Frida JavaScript API, and load various scripts. As you can see here, we simply need to launch Frida and attach to a process or application. Once attached, we can run a variety of commands from the CLI. Conveniently, the interface includes an autocomplete helper to give us options. In the next module, we'll start using more of these features while scripting. Let's now take a look at Frida LS devices. This tool provides a list of devices along with their IDs and types, indicating whether the device is local, USB, or remote. This information is useful for identifying the target device you want to work with, especially in setups with multiple devices connected. The output contains 4 fields: ID, type, name, and OS. Now let's take a look at Frida PS. As you might have guessed, Frida PS is used to list processes on our target device. The examples listed here are some common iterations of the command line you'll be using. Simply using the -U flag will list all running processes on the device connected via USB. Adding a lowercase a to that flag will list only the running applications. Now, adding a lowercase I will list installed applications, not just those running. You can also use the -D flag and specify a device serial to connect to. You'll get this info from Frida LS devices, which is especially useful if you have multiple devices connected. Let's review. In this example, we connect to our device over USB, and we want to list installed applications on that device. Now let's see this tool in action. If you ever forget the flags, you can run Frida PS with the --help option to get more information. Using the -UAI flags will print out a list of installed applications, their PID if running, or process ID, and their package identifier, which can be used to spawn the app. Adding J to these flags can also print out this information in JSON. Let's jump into something a little more advanced now. Frida Trace. Frida Trace is designed to automatically generate and run hooks on selected functions in a target process. We use this for tracing function calls and understanding how an application behaves at runtime. This first example shows how we can use Frida Trace to generate hooks for native functions, or those that are written in C or C++, and use the platform's respective bridge to interact with the application. Like other Frida commands, we use the -U to indicate we're connecting to the device over USB. -I is the flag that specifies we're instrumenting a native function, which is then followed by the target function name, and finally the process we're executing. Either the package identifier or the app name from Frida PS. If found, Frida Trace will generate a basic hook template in the handlers directory for that function. You can then further edit those scripts, which we'll show in just a little bit. We can also trace all functions with a module by using the -I, capital I, flag. We can use the exclamation point asterisk wildcard at the end of the module name to instrument all functions within that module. A hook template will be generated for each function found and placed in the handlers directory. In this example, we're using Frida trace to instrument all functions with the open JDK native library. We've added a wildcard for the function so that all will be matched and handlers will be created for each. Wow, 535 functions in total are now hooked. We can also use Frida trace to hook Java methods used by Android apps. For this, we use the -J flag, followed by the convention of method name, exclamation point, function name, and finally, the process we wish to trace. Now, let's say we want to trace all classes within JavaX crypto package, and all functions within those. With this trace command, you can see that we are getting hooks for various key agreement, cipher input stream, and related functions. Using the -M flag, we can trace Objective-C methods as well, in much the same way as Java and native methods. Notice the Objective-C convention of using square brackets. Outside the square brackets, you can specify if the method is an instance or class method. And as always, wildcards may be used. Now let's look at an example on iOS. The NS File Manager class provides iOS developers an interface to the contents of the file system, and the means to interact with it. We can trace this class and watch as our sample app interacts with the file system. Now we could use a wildcard to hook all methods in the NS File Manager, but as you saw in previous examples, there are going to be a lot of traces and subsequent handlers generated for such a large class. Feel free to try it on an app of your own to see how many results you'll get. We could look up developer documentation or just start with functions starting with file, for example. One method we might find interesting is file exists at path, which accepts a file path and returns if that file exists or not. Tracing the file exists at path method shows a fair amount of instances of that method being used throughout the app. If we wanted to get more information from that method, we could edit the handlers file to return additional data. A handler file defines how the trace functions should be hooked and logged. These handler scripts are stored in a directory named after the target process, and they can be customized to perform additional actions such as logging more detailed information or modifying the behavior the function calls. When we open the file exists at path handler, we see the auto-generated structure with an onEnter and onLeave function. The onEnter function is executed with the specific function that is called. This function allows you to inspect and manipulate the arguments of the native function, log information, and perform any other actions you might need before the function actually executes. Similarly, when the function is executed and about to return to its caller, the onLeave function is executed. This allows you to perform similar functions as onEnter, but after the function has executed instead of before. We can modify these files to log more information, but don't worry, if you mess it up, just delete it and it will be regenerated. In the case of this modification and handler, we want to see what the file path actually is in readable text. Right now, we're outputting the argument as a reference location. The use of Objective-C or objc.object creates a JavaScript binding to the specified args object. As you can see, we're now able to see the file path. Method mangling is a technique used in programming to create unique names for methods, especially in the context of object-oriented languages where methods can be overloaded. When reverse engineering the application binary, make sure you pay attention to mangled names. You may choose to use a utility such as nm demangle or swift demangle to see the demangled name, which may be more human readable. But remember to use the mangled name when you're writing a script. Let's move on to Frida Discover. Frida Discover is designed to automate the discovery of interesting functions within a target application. It simplifies the process of identifying functions that can be hooked and instrumented for further analysis. Think of it as a trace all utility. But be warned, sometimes the scope is limited and may not pick up every traceable function or method. It may also cause instability in the app, especially larger ones. Some example Frida Discover output might look like the following. Now let's wrap up our toolset module with one final tool, Frida Kill. Frida Kill is a command line tool for killing processes with a specified device ID and PID, which you can get from Frida PS. Why would you need that? Well, amongst other reasons, you might need to terminate the process to prevent it from continuing to run, especially if it's in a state that could cause issues. You might want to ensure that processes are cleanly terminated between test runs, or you may need to forcefully terminate just completely unresponsive processes. Well done. You're almost finished with this module. In this module, you learned that there are several built-in tools that will aid your Frida experience, but remember to use them wisely. These tools can work with both native and Objective-C, Swift, Java style methods for a truly cross-platform experience. And Frida Trace can jumpstart your tracing of target methods and functions, but the real power lies within the modification of handlers that are generated. Before we end, I invite you to take advantage of some of our hands-on exercises. Please pay close attention to the requirements for each exercise. If you don't have the requisite tools or devices, feel free to skip or come back to later. Exercise 1. If you have access to a jailbroken iPhone, follow the link on this slide and download the MASTG OWASP JWT Swift app. Install it on your phone. Now follow the directions shown here. Feel free to pause while you follow the instructions. In the next section, we'll review the solution. Now, as you go through this exercise, keep in mind the following questions. Were you able to convert the arguments into a readable format? And then can you use the NSURL session documentation, the developer documentation, to find out how to also print out items such as the method, the headers, and the body of that request? Go ahead, do this now. Feel free to pause and come back to this later. Stop. If you haven't yet completed the exercise and you wish to without any assistance, please pause the course at this time. If you're ready to see the solution, or you need a little bit of help, feel free to click on. A quick search through Apple's developer documentation shows us the various request components that we can access. We can now create an Objective-C request object from the argument and access its various components. Once we trace the initial data task with request method, we can update the handler to look something like the following. And finally, once updated, this is the trace output you should expect to see from a modified handler. Notice the addition of the method, URL, the headers, and the body, all output to the screen. Thank you for viewing this module of the NowSecure Academy Learning Series. In Module 3 and 4, we'll take what we've learned so far and apply it to scripting for Frida on Android. Get your Android devices or emulators ready. We'll have some fun companion exercises as well as a few challenges to test yourself along the way. For more information and to develop your mobile AppSec knowledge, make sure you check out the rest of our existing catalog of courses at NowSecure Academy.